relationships, different types of angles. We have what's called vertical angles. I don't know if you remember hearing corresponding angles, alternate interior angles from geometry. So we're going to simply talk about all the different types of angles that are out there and some of the relationships between their angle measures for those different types of angles. So if you simply take two lines that intersect, right away you have this situation happening. We call these vertical angles, angles that are kind of across from one another. So in terms of naming me a pair of vertical angles, you could say angle QMN and angle RMP are vertical angles. They share a vertex and they're somewhat across from one another. And then likewise angles, the other two angles, and sometimes angles can be named by using a number. I don't know if you recall geometry or not, but sometimes you saw the situation we could say there's angle 3 and angle 4. Those would also be considered a pair of vertical angles. And what's true about vertical angles all the time is that they will always have the same measure. They're congruent to one another, same number of degrees. Now, why is that the case? If you were to prove that that's true for all pairs of vertical angles, let's just call this angle QMR. Let's just say it has a measure of x degrees. Now, what do you guys know about angle QMR? Wow, I didn't want that to happen. QMR, picked the wrong pen. What do you know about angle QMR, the one I have labeled X, and the one that I have labeled QMN? What do you know about those two from last time?
180 degrees.
They're supplementary, right? They add up to be 180 degrees. They form a straight line. So if this angle has measure X, then that means the other angle has to have measure 180 minus X, right, in order to get 180. Now, continue on around. What has to be true about this angle and this angle? Well, they also have to add up to be 180. So that forces this one to be X. Why? Because I need to add these two together to get 180. So as you can see now, it forces those two to be the same measure. And then as I keep on going around, this one has to be 180 minus X. All right, so vertical angles are always congruent. Next item I want to talk to you about, various types of angles. Talk about what parallel lines are, which you know what parallel lines are. Two lines in the same plane that do not intersect. Got to be in the same plane. Another situation is you could have two lines in two different planes and not intersect, and those are not called parallel lines, those are called skew lines. But in this class, everything will be in the same plane. So we got parallel lines, we got something called a transversal, and then we have all these other types of angles. Corresponding, alternate interior, and same side interior angles. Let's start with parallel lines. Like I said, those are the two lines that I have up here in blue. Two lines in the same plane that do not intersect. So we would say up here that line M, is parallel to line N. And then comes line Q. Q is what we call a transversal. It's a line that is intersecting a set of parallel lines. And the minute that I see that line Q intersects lines M and N, right away, 8 angles are formed. And I have them numbered up here, right? 1, 2, 3, 4, 5, 6, 7, 8. We're going to now try to identify angles that are alternate interior, alternate exterior, same side interior, and corresponding. Let's start with alternate interior. Alternate interior simply means inside, interior meaning inside the parallel lines. Alternate means different sides of the transversal. Okay, again I'll say inside the parallel lines, different sides of the transversal. So if I call out angle 3, what other angle up here is inside the parallel lines on the other side of the transversal? That would be angle 6. So 3 and 6 would be a pair of alternate interior angles. 4 and 5 would be considered alternate interior angles. Okay, that's just locating them. Now, what do you think is true about them?
They're congruent.
They have the same measure. Okay? So alternate interior angles have the same measure. And it's only when those two, M and N, have to be parallel for any of this to be true. You can all see, right, that if I took line M and ever so slightly moved it like this, where M and N are no longer parallel, then you can see all of this is off. Those two angles would not be congruent. So let's label up here, alternate interior angles are always congruent, or they have the same measure. How about alternate exterior angles? Alternate exterior means alternate, opposite sides of the transversal, outside the parallel lines. So if I say angle 2 is one of them, what would be the one that goes with angle 2? Other side of the transversal, outside, would be angle 7. Likewise, angle 1, angle 8, and the relationship between alternate exterior angles is they're also congruent to one another. So far everything's been congruent. Okay. Questions so far? Next one, type that we'll locate, same side interior. Same side, now we're saying same side of the transversal inside the parallel lines. So that would be angle 3 and angle 5. Clearly not congruent. Also another pair would be 4 and angle 6. And what do you think the relationship is between those?
Supplementary.
They're supplementary. They're going to add up to give you 180. So the measure of 3 plus the measure of 5 equals 180 degrees. So same side interior angles are always supplementary. We can start proving a couple of these things later on, but it all is based upon the fact that vertical angles, the very first pair that we talked about, are congruent to one another, which I'll show you what I mean in a minute. Let's finish up with the different types of angles. Finally, we have what's called corresponding angles. And I want you to think corresponding angles in terms of position, meaning pick any angle up here, 1 through 8. Let's pick angle 5. Angle 5 is above the parallel line to the left of transversal. So what other angle up here is above and to the left of transversal? Anybody? Angle 1. Those are what we call corresponding angles, and corresponding angles are congruent to one another. Quickly, another pair of corresponding angles. If I choose angle 8, 8 is below the parallel line to the right. 4 is below the parallel line to the right. They have the same measure. All right? And you can see how we just simply have a chain reaction of properties up here. Meaning, let's just call angle 1 x degrees. Well, 1 and 4 are vertical angles, right? 1 and 4 are vertical. So 4 would have to be equal to x. X and 2, angle 2, supplementary. They form a straight line. So this would have to be 180 minus x. Therefore, this one is 180 minus x. Okay? Let's keep on going with this. What has to be true? We know that angles 4 and 6 are supplementary. This one would be 180 minus x. And then right away you can see that alternate interior angles are congruent to one another. Again, jumping across, angles 5 and 6 have to be supplementary because they form a line. That makes that one x, that makes that one x, and that one makes 180 minus x. So you have all kinds of congruent and supplementary properties going on with these 8 angles. Right? With me so far? So out of all these different types or pairs of angles, again, alternate interior are always congruent or equal. Alternate exterior are always congruent. Same side interior are always supplementary, and corresponding angles are always congruent. Any questions or concerns so far? Now, I'm going to start you off with one of the basic problems that you'll see in your homework, and then those types of problems will get more and more complex. One in particular, you're going to start seeing pictures now where it's your job to come up with either solve for x or actually come up with angle measures. So when I look at those two angles that are labeled, of the four types of angles that we just talked about, what type would those two be? Alternate exterior, and you know what's true about them. They're equal to one another, so you'll say that 3x plus 2 is equal to 5x minus 40. Solving for x, we get 2x on the right, add 40, we'll get 42 on the left, divide by 2, x is equal to 21. Now they want us to actually find the angle measure, right? So I'm not finished yet. All I did was find x. Let's go ahead and substitute 21. Doesn't matter which one we use, right? Because they're equal to one another. So what's 5 times 21 minus 40? Looks like 105 minus 40. What is that? 65. So therefore answer is 65 degrees. Questions or concerns so far? You're like, when's this stuff get more challenging? Yeah, it will. You guys ever hear this called the triangle angle sum theorem? Simply means, and you've probably been told in the past sometime in your life, that angles of a triangle will always add up to give you 180 degrees, right? The three angles of a triangle always add up to be 180 degrees. And we're going to, two ways we can prove it is if you actually take a triangle, construct a triangle with a pencil and a ruler, tear off, like they're showing you here, right? Tear off the three angles. You can then take those three angles and line them up, and as you can see, they form a line. They will add up to give you 180. Now, a problem with this proof is that you're only showing it for one triangle. What about all the other triangles out there that you can draw or construct? What about all the obtuse triangles? What about right triangles? What about acute triangles? So the formal proof for why do those angles add up to be 180? Let's say you start with an arbitrary triangle. Now the one that I draw ends up being an acute triangle, but just please know this works for all triangles. You can actually do this with a right triangle, and you can actually do this with an obtuse triangle. Start with a triangle, and I want you to pick one of the sides, and I want you to pick the vertex or the point across from that side. So I'm going to choose this side, and I'm going to choose this point across from that side. And one of the properties that you learn in Euclidean or plane geometry is given a line and a point not on that line, there exists exactly one line through that point parallel to the given line. In other words, that's the only line I can draw through that point parallel, oops, let me get the pen, parallel to the given side, right? And now what's just happened? Well, our job is to show that 1 plus 2 plus 3 adds up to give me 180 degrees. And I've just created two more angles that I'm going to label 4 plus 5. All right? We want to show that the measure of 1 plus the measure of 2 plus the measure of 3 is equal to 180. So let's start with, well, what do I know about 1, 4, and 5? I know that these three give me 180 degrees. They're all supplementary. They form a straight line. So I know that angle 1 plus angle 4 plus angle 5 is 180. What do I know about 4 and 2? Let me make it stand out a little bit easier for you. Do you remember this picture from the last page? What do I know about 4 and 2? They're congruent because they are alternate interior angles. Same thing with 3 and 5, alternate interior angles. So let's do a substitution. Out comes the 4, in goes 2, substitute out from 5, in goes angle 3, and therefore you show that the three angles of triangle add up to be 180 all the time. You can do this process no matter what the triangle looks like. Any questions there? Moving on. Some vocabulary. We can take triangles and we can classify them according to what their angles look like, or we can classify them according to what their sides look like. So according to classifying triangles in terms of their angles, if all three angles are acute or less than 90, we say that the triangle is an acute triangle. If you have a right angle in the triangle, it's called a right triangle. And if you have an angle greater than 90, we call it an obtuse triangle. That's classifying a triangle according to angles. According to sides, if all three sides are different in length, we call that a scalene triangle. If at least two sides are equal, we say an isosceles triangle. And then finally, all three sides equal, we call that an equilateral triangle. You may have heard these before in other classes. Other triangle relationships. If I hand you two triangles, and again, remember, you're probably recalling back when you had geometry maybe in high school, you were always asked to prove two triangles are similar or prove that two triangles are congruent. What congruent means, same size, same shape. Meaning, if I hand you two triangles and they are congruent, you can place one on top of the other and it looks like you only have one triangle. Same size, same shape. Similar, on the other hand, they have the same shape, but they have different size. Meaning, one is an enlargement or a reduction of the other. It's like a mini-me of a triangle. So, again, same size, not same shape. The second one, similar triangles, is the one that you and I are going to focus on for the remainder of this course. So two things have to be true for triangles to be similar. Corresponding angles are the same, but in terms of their sides, there's some type of ratio relating the sides, corresponding sides together with one another. So corresponding sides are proportional. That is, their ratio must be equal the whole way around the triangle, comparing one triangle to the next, which I'll explain more in more detail. For example, first word problem says, firefighters at this fire station need to measure the height of the station flagpole. They find at the instant when the shadow of the station is 18 feet long, the shadow of the flagpole is 99 feet long, the station is 10 feet high, find me the height of the flagpole. So we're going to label that X. And by the way, any of you remember back in school, did you ever go outside, use shadows to find the height of something? Anybody, you did? I can remember doing it. You did? You're using similar triangles here. The two triangles are similar due to the angle-angle property that I don't want to get in detail. But what is true about two triangles when you know that they're similar is first you have to orient them the right way. Make sure they are both oriented in the same direction, right angle lines up, etc. But the angles are still congruent. So we have the right angles corresponding with one another. This angle right here would have the same measure. If one's 28 degrees, the other one's got to be 28 degrees. And then finally, these two angles would be congruent to one another. Now, in terms of their sides, they have to share a common ratio. So as you can see, what two sides up here would be corresponding with each other that I do know the lengths of? This one right here and this one right here. So that ratio, whatever it ends up being, 88 over 99, or 18, I'm sorry, over 99. That's the ratio that must be shared the whole way around. Okay? We're being asked to find out how tall this flagpole is, X. So we're going to set up a proportion. 18 units in the small triangle corresponds to 99 units in the large triangle. Where does my X go? X is related to the large triangle. It's going to go down here. And what side is corresponding with X? The one labeled 10. It goes up top. And so now I simply solve this proportion by cross multiplying. We say that 18x is equal to 99 times 10, or 990. Divide both sides by 18, and 990 divided by 18, someone help me out.
55.
Exactly? Thank you. So the height of the flagpole is 55 feet long. using similar triangles. Again, I'm giving you kind of an overview, but most of the remainder of the class period today, I'm going to let you start working on some of the problems I've got selected on the syllabus. You need to take this concept, and some of the problems are a little bit more involved, but it's all going to boil down to angle relationships, maybe similar triangles. Okay? That is it.